Okay, welcome to lesson 1.4. We're going to model and describe whole numbers. This is the second part of that lesson. So now we're talking about factors and greatest common factors, GCF. So it says factors are numbers that are multiplied. So that's the missing letter or the missing word. We're going to write multiplied. So make sure you're keeping up and filling in the blanks here. We've got lots of little blanks for us to fill in. Okay, our example here says we have a 6 times 5 equals 30. So the numbers that are being multiplied, we call those factors, okay? Instead of just saying, hey, we got the number 6 and the number 5, we actually say we have factors 6 and 5. That tells us that they make a bigger number. So the minute I use the word factors, this is vocabulary, if I say I have 2 factors, that means they're multiplying to give me a bigger number. So 6 times 5, they are multiplying to give me my bigger number of 30. So I have a factor times a factor gives me a multiple. So multiples are the bigger numbers, okay? And the factors, these are the smaller numbers. Now, you can also get a factor that's exactly the same size as your original number. How come? Because every number divides by the digit 1. So, for example, another factor of 30 would be 1 times 30. So the number itself is the largest that it would be. So if I am factoring 30, 30 is the biggest number that will divide into it. No other bigger numbers. If I want bigger numbers, then I'm talking about multiples. Okay, that's the difference. So multiples, that's when we skip count and get bigger numbers, or we multiply. These ones are smaller numbers that multiply to give a bigger one. All right, so it says factors are useful when determining how many different ways these boxes can be stacked and arranged in a warehouse. So how many boxes do I have altogether? Well, it says I've got 6 boxes. I've got 1, 2, 3, 4, 5, 6 on that side, and I've got 6 on the other. So I would have a total of 12. So if I were to say I've got factors of 12, we're going to make a factor chart. This is called a factor T-chart. And you always start with the number on top, and then you make a letter T. So I'm going to make a letter T. And now I always divide. So I'm going to divide my number 12 by smaller numbers. The number I always start with is 1. So it'll divide by 1, and I'll get 12. So 12 dividing 1 gives me a 12. It's an even number, so I'm going to divide it by 2. If I divide 12 by 2, I get a 6. Okay, it's an even number. I'm going to try and divide by 4. Darn it, 4 doesn't work, or 4 does work. But 4 times 3, we put the smaller numbers on the left, bigger numbers on the right. 4 times 3. How do you know when you're done your factor chart? When the numbers are either identical or really close together, where they only have 1 number difference or 2 or 3 numbers difference. That's when you know you're done. Because now the numbers would reverse. I would divide by 4 and get a 3. Divide by 6 and get a 2. Divide by 12 and get a 1. So I would say the factors of 12... The factors of 12 are 1, 2, 3, 4, 6, and 12. So how many factors does that guy have? 12 has 6 factors. Okay, it's got 6 numbers that can multiply to give me a 12. That's what it's telling me. Now we're going to do the number 6. The number 6, I'm going to draw a factor T-chart over here. And we're going to see what the numbers they came up with. Well, they're showing us the numbers already. Well, we're going to do it in our T-chart. We always start with the number 1. 6 divides by 1 and gives me a 6. Okay, so you're always dividing. Dividing by the small numbers on the left. Okay, so I'm going to go 6 divide 1. 6 divide 2 gives me 3. Well, those numbers are sitting side by side on the number line. So now I know I'm done. Okay, so my factors are 1, 2, 3, and 6. And that's what they're telling us here. 1, 2, 3, and 6 are my factors of the number 6. So that tells me those 4 numbers multiply to give me a 6. And they do the same thing for the number 24. So the number 24, they've reversed the T-chart. They've got the 24 like this, and what they've done is they've put the small numbers on the right, big numbers on the left. We like the small ones on the left. This guy's just reversed. So if I were to draw this one, I would always put the small numbers on the left. 1 and 24, 2 and 12, 3 and 8, 4 and 6. My numbers will reverse, I'm done. Okay, so we like to keep the smaller numbers on the left. Okay, this guy here, it's fine, but he's written backwards. Okay, we like small numbers on the left. All right, we still get the same answers though. So here are all the factors of 24. We end up with 8 numbers. 4 pairs of numbers. All right, turn your page when you're ready. Now, there's 3 steps to find factors. How do we find factors? This is the ways we do it. Step 1, 1 and the number are always factors. So step 1 is, in our own words, divide the original or the starting number by 1. Okay, we start by dividing by 1. And this is creating a factor T-chart. That's what we're creating. Small numbers on the left, big numbers on the right. If it's an even number, we divide by 2. Okay, divide by the number by 2 if it's even. And what if it's even? What if it's not even? What number should we start with? If it's an odd number, we divide by 3 to start. Okay, we have a lot of dividing rules. If it ends up ending in a 5, we divide by 5. Logan, pay attention, please, and write these down. Gage, make sure you're writing these down, please. Gage, write this stuff down, please. No being lazy.
I'm not lazy. I just had a bug in my eye.
Okay. All right, so if it's an odd number, we start dividing by 3. And the thing that's important here is this. If we get a whole number, then that means that number is a factor. If we get a decimal, that means the number doesn't work and it's not a factor. Okay, if you get a decimal number, it's not a factor. It doesn't work. So that could be if you're dividing by any number. If I took the number 10 and divided by 7, I'm going to get a decimal number. It won't work. Okay? And then we keep dividing by consecutive numbers. What does it mean by consecutive? Who remembers what that big word means? It's showing you what it is. 3, 4, 5, 6. So what do you think consecutive means? Yeah, the numbers in a row. They're going up by 1. So you're just going to start dividing by the number 1 always. If it's even, you start with 2. Then if it's odd, you'll go to a 3. If it ends in 5, you're going to go to a 5. Otherwise, you're going to divide by all these numbers in a row. Some of them are going to work, some of them won't. The ones that give you decimals don't belong in our factor T-chart. Okay? So, not a factor. These don't go in the T-chart. Okay, so the ones that make decimals don't go in the T-chart. Only the ones that are whole numbers go in our T-chart. All right. And it says here on the big exclamation mark, you will know when all of the factors have been found when you divide a number by something that you've already got in your factored list. So that means the numbers reverse. Okay, and then you're dividing by those same numbers. So here's an example. Is 5 a factor of 125? Well, what did we say that 5 divides into? What is our rule for 5s? Rule for 5s. What's our rule? Who remembers? It says it right here.
What?
If the number ends in a 0 or a 5, it can be divided by 5. Okay? So, rule for 5s is right there. If the number ends in a 0 or a 5, it can be divided by 5. So that means if it can be divided by 5, it gets the special name factor. Okay? It gets the special name factor. So that's why they're saying over here that 5 is a factor of 125. He is a factor because he divides in there and he does not leave us a decimal answer. That's what that means. So it's showing us right here. It divides by 5 and we get no decimal answer. That's why he is a factor. So conclusion, it says 5 and 25 are both factors of the number 125. Absolutely they are. If we were to make our T-chart, both numbers would be in there. So what does it say? It says factor lists, and the lists come usually from our T-charts. So factor lists and sets are helpful when finding factors of a number. So we're going to factor the numbers 18 and 24 using factor charts. It says, then we will write the set of numbers for each number. Now, how do we write a set? Well, they get those curvy brace brackets. That's how we know it's a set. Okay, so the special word set, where is it here? The set, it's because it has these curvy braces. Remember, those curvy brackets are called braces. So the minute it gets those, we've now included it saying, here is our set of numbers. Okay? All right, so let's make factor T-charts. So my T-chart for 18. And then I need a T-chart for 24. All right, what number did I tell you we always start with? 1, good. So 1 times the number itself. So 1 times 18. Now 18 is an even number, so what number could we divide by again? What's our first even number? 2. So 18 divides by 2, I would have my calculator, I'd say 18 divide 2, and I'd get a 9. So what we're doing is we're dividing by the small numbers on the left. So we're dividing by all those small numbers on the left, and that's giving us the answers on the right. So now if I take 18, we got, what's the next number after 2? 3. Okay, so we start with 3 and we see if 3 works. And we see, yep, 3 works. I don't get a decimal when I try it. So 3 times 6. Okay, and what are the numbers in between 3 and 6 now? 4 and 5. So now I have to try the numbers 4 and 5. So 4 and 5 are between 3 and 6. So we're going to try and divide by 4 and 5, but they don't work. Okay, but they make decimal answers. And if they make decimal answers, they are not factors. So they don't go in our factor T-chart. Only the ones that are factors go in our factor T-chart. Yes, Miss Jamie?
So when you're doing this, the key is you need to have your calculator out. It's trial and error, right?
You bet.
You just type it in.
Yep, it's a guess and check. You betcha. Okay. So we grab our calculators and we are going to start dividing by all these small numbers. And now when I divided by 3, I got a 6. So now I'm looking at the numbers in between 3 and 6. And I have 4 and 5. If I divide by 4, I get a decimal. If I divide by 5, I get a decimal. That's how I know I'm done, because then the next number would be a 6, and I know 6 works. Okay, so the minute we get to this number, our bottom number on the right, our numbers would reverse. So that's how we know we're done. So this is guess and check with your calculator. You need to have your calculator out for this. And the same thing is going to happen with the number 24. We're going to start with the number 1. 1 times 24. Okay, so if I divide by 1, I get a 24. It's an even number, so I'm going to divide by 2. If I divide by 2, I'm going to get a 12. No decimals, so I know 12 works. Now I'm going to divide it by 3. Does 24 divide by 3 without a decimal? You bet. I get an 8. What's the next number after 3? 4. So I'm going to try the number 4, and it works. I get a 6. What is the only number in between 4 and 6? 5. And does my number end in a 5 or a 0? No. So I know 5 won't work. So that is my only list. So now I've got these 4 numbers I divided by, and I got these answers without decimals. I know I did it right then. So now I'm going to write all these numbers in my list. So the way I do that is you have to write it smallest to biggest. So the way it actually goes in your factor charts, you're going to make like a letter U when you're writing your numbers. So you're going to go down, and then you're going to go back up. And that's the order of the numbers. And yes, the order of the numbers matter. Okay? So you're going to start on the top left. You're going to write all those numbers. Then you're going to go to the bottom right and go up and write all those numbers. And that puts them in order, small to big. So let's write our numbers that we found that are factors. So always the number 1. Then we try the next 2 and 3. They worked. 4 and 5 didn't. I got a 6. I have a 9 and an 18. So there is my factors of 18. Now I'm doing factors of 24. And you're going to notice all of these numbers are smaller. So the smaller numbers multiply to give me my bigger number. Okay? So I get a 1, a 2, a 3, and a 4. I've done all the ones going down my left. Now I got to go back up the right side. So I'm going to get 6, 8, 12, and 24. Now we're going to do something really cool. Now we're going to do what's called greatest common factor. And what that means is once I've got my 2 lists built, I try to find out what numbers they have that are identical. Do they have any identical numbers? Yes, Riley. Yes, you can. Oh, not Wyatt's first. So Wyatt, do you still have to go? Pardon? Oh, Noah's out. Oh, sorry. Okay. It just wasn't wiped off. Okay. And then Logan, and we're going to put Riley's name under Logan. Thank you. Okay. So now what we're going to do is we're going to circle the ones they have in common. Circle or highlight. So I'm going to grab my other highlighter color. I'm going to grab my dark blue, and I'm going to say, okay, they have the 1s in common. They have 2s in common. They have 3s in common. They have 6s in common. Do they have anything else the same?
6. Oh, yeah, you did.
They only have those numbers the same. Who would be the biggest? 6 is the biggest. So we would say our biggest one, that's called our greatest common factor. So we would say our GCF is 6. It's the biggest one. Okay, it's the biggest one in both sets that they have in common. Go ahead, Logan. Okay, next page. So once you've got that written down, we're going to actually talk about that greatest common factor. So the greatest common factor of a pair of numbers is the largest found in the factor sets or the factor lists. So we wrote both of our factor lists, and it's good to write them top and bottom of each other so that you can actually see the numbers like we just did. So we found that we had the number 1 and 2 and 3 that were the same, and we have a 6 the same. The biggest number is the one that we call the greatest common factor. So let's take a look at another example here. It says, what is the largest size of tile, if this is our pretty tile we're using here, for a tile floor? It says, what is the largest size of a tile that will cover that type of floor? Well, we need to do the factors of 6 and 4. So we need to do a factor chart of 6 and a factor chart of 4. All righty, what number do we always start with, folks? Uno, 1. So 1 times 6, what's our next number? 2. I divide by 2 and I get a 3, I'm done. So I know those are my factors of 6. Now I do the same thing to the number 4. I divide it by 1 and I get a 4. The next number after a 1 is 2. I divide by 2 and it works, I get a 2. All righty. Now we want to find the number they have the same in their lists. So they wrote their lists out here for us, right here. There's the lists. And I'm going to highlight again which ones are the same. They have these ones and these ones. Which one of those numbers is the biggest? 2 is the biggest. So 2 is the GCF. So for this problem solving question, that means my tile has to be 2 feet by 2 feet. It's got to be a 2 by 2 tile, okay, in order to cover that floor. Now, to find the greatest common factor, here are your general steps. Steps to find your GCF, right here. So it tells us, list all the factors from both numbers in order from smallest to biggest. That's what we've done here, and that's what we did in the previous example. So we list them from, and that's the important part, they have to go smallest to biggest. Okay, and you're going to list all the factors. Then you circle or highlight the biggest one. The biggest one that is common to both sets. So it has to be in both numbers, both lists. And that's our biggest one. All right, let's take a look at our example on the bottom here. It says find the greatest common factor of 20 and 45. So it already did our factor charts for us and it listed the numbers. So now if we were to take our handy dandy highlighter, I would notice I have the numbers 1 in common, I have the numbers 5 in common, and that's all. If we kept going, actually we can't keep going. Those are the only factors. So the only number they have in common is the 5, that is the bigger one. 1 goes into everybody. So whenever you get the only number that is 1, if only the number 1 will divide into, let's say some numbers, that's the only number we say there's no greatest common factor. So for example, if I were to write, whoopsie, let's get a pencil here. So if I were to write the number 7, the only factors of 7 are 1 and 7, and maybe the factors of 5. Factors of 5 would be 1 and 5. Well, whenever you get only the digit 1 as a common number, we would say there's no greatest common factor. We would say there is no GCF except the digit 1, and 1 will divide into every number. So if the only thing you can circle the same is a 1, then there's no GCF. Okay? So no GCF if number 1 is the only identical number. All righty, turn your page, folks. Once you've got that written down, I'll give you a sec. Okay, continuing on, multiples versus factors. So multiples of 6, these are numbers that start at the number 6 and then get bigger. Okay, so these guys start at the original number and get bigger. These guys are smaller than, I should say smaller and equal. Smaller and equal to the original number. So that's kind of a good way to remember which ones are which. The bigger numbers are multiples. The smaller numbers are factors. And again, this is where we make our t-chart. We would make a factor t-chart here. And I would have 6 on top. I would divide by 1, I get a 6. Divide by 2, I get a 3, and I'm done. So from my factor t-chart, I put my numbers in a list. Okay? In a list or a set. Same thing from the multiples. Multiples, this is where you're either skip counting or you're multiplying by 1, 2, 3. Okay, so or skip count. All right. Now we're going to talk about composite and prime numbers. We're going to get more detailed. So far we just know about whole numbers and we know about multiples and factors. Now we're talking about composite numbers. So composite numbers are numbers that can be divided by more. The key word in this one is more. So they can be divided by more numbers than just the number 1 and itself. So these numbers have more than 2 factors. Okay, they've got more than 2. So if we look up at our factor chart, the number 6 has more than just 2 factors, 1 and 6. It's got the 2 and 3 as well. So these guys have 4 factors. The prime numbers are the ones that only get 1 set of factors. So this is where we differentiate now and start talking details. So prime numbers are numbers that can only be divided by 1 and itself. So divided by 1 and itself. They have 2 different factors. And that's an important word there, different, because that tells us why the number 1 is not a prime number, because it has 2 identical factors, 1 and 1. So 1 times 1 makes a 1. There's no other numbers that you can combine that will multiply to give you a 1, just 1 and 1. And those are identical digits. So because they're identical digits and they're not different, the digit 1 does not get the special name of prime number. Same with the number 0. So it says prime numbers are the building blocks. The building blocks of all other numbers. We can break down any number into its prime numbers. Please be filling in the blanks. There's not much for you guys to fill in, but you need to be following along. Gage, that includes you. Okay, then use your pencil. Fill this stuff in. Don't be lazy. Okay, then do it, please. I know that. But I'm not giving you the choice, because if you don't want to work in here, you'll work in Zap. And Zap is after school on Tuesdays and Thursdays with Miss Lambert. So if you'd rather be there to do your math, you choose.
Today's Monday.
That's right. So if you don't do your work today or tomorrow, I can send you to Zap for anything for any time.
But I have surgery tomorrow.
Okay, then you better get it done today.
For my pinky toe.
Okay, we'll get it done today then.
It's in the morning.
Okay. So any number can be broken down into prime numbers that multiply to create it. There is only one set of prime numbers that can be used to create any number. When we find 2 or more prime numbers that multiply together to make a larger number, we call this prime factorization. Prime. The word is down below on the left. You can see the spelling of it. Prime factorization. This is finding which prime numbers you need to multiply together to get the larger number. Okay, so there's a few blanks for you guys to fill out. It says the number 10 is a composite number because it can be divided by more than the number 1 and 10. If we make a factor chart, we are going to see that the number 10 has multiple factors. So here's our factor chart. We get 1 times 10. Every number divides by 1. And now it's an even number, so we divide by 2. I'm going to get 2 and 5. Now I take a look at the numbers between 2 and 5. I got the numbers 3 and 4. So I try to divide by 3 and 4, and I get decimals. So that means the number 3 and 4 are not factors of the number 10. They don't fit in my factor chart. That's what that tells me. Okay? So the only factors are 1, 2, 5, and 10. So here's my list of 10. 1, 2, 5, and 10. So since there's more than just two numbers, 1 and 10, this guy has multiple. I have extra numbers in there other than just the 1 and the 10. So that means this number is composite. So this also gives us a hint. All numbers except the number 2 are composite. So all numbers that can be divided by 2, so all even numbers except the digit 2. So we can write a little note to ourselves. All even numbers are composite, except number 2. He's special, he's prime. Okay, so all even numbers can be divided by 2, which means they can be divided multiple times, except the digit 2, because he can only be divided once. All right, so we've got the first 7 prime numbers listed. The number 2 is the only even. He is the only even prime number. The only even one. Every other prime number you're going to see is an odd number. So that means it ends in a 1 or a 3 or a 5 or a 7 or a 9. Okay, that's what the numbers would end in if they are going to be odd. Okay, and it's showing us a list of composite numbers. Again, composite numbers are even and they can be divided by 2. Are there composite numbers that are odd? You bet. The number 15. 15 is an odd number, but it can be divided by 3 and 5, not just 1 and 15. All right, so it says an easier way to find prime numbers is to use factor trees. So let's factor the number 48. It says that means find 2 numbers. So whenever I say to you, let's factor, that means, okay, write down what it means. I'm giving you explanation here. And the reason I do this is so that if I'm not sitting with you, or Miss Jamie or Miss Nemish, if we're not sitting beside you, you can read this and remember how to do it. It's got the steps for you. So it says it means find 2 numbers that divide into that 48, other than the number 1, because we know 1 divides into everything. So typically, because it's even, we start with the number 2. Okay, but if you think of 2 other numbers, like I'm showing 48 here, we can think of the number 6 and 8. They're both even. You could think of 12 and, you could think of 2 and 24. Okay, 12 and 4. There's lots of different combinations to make 48. So 48 would divide by 6 and 8. The 6 breaks down into 2 times 3. The 8 breaks down into 2 times 2, 2 times 4, and the 4 will break down into 2 times 2. Let's do it with other numbers. So let's say I'll use 48 again. Whoopsie. Let's use my other color, not my highlighter. Okay, so if I used 48, and let's say I use the numbers 2 and 24. You can use anything as your first 2 numbers. It doesn't matter, as long as it's not the number 1. Okay, always start with 2. If it's an odd number, start with 3. If it ends in 5, like it shows us here, if it ends in 5, divide by 5. If it ends in a 0, we would do dividing by 10 to start. So those are some dividing reminders. Okay, so if I use 2 and 24, we know 2 doesn't break down, but 24 is even. He'll divide by 2 and I get a 12. And then 12 will break down into 2 times 6. And 6 will break down into 2 times 3. So now let's take a look at how many 2s and how many 3s I get. So if I'm going to highlight the number 3s in green, I've got 1 3 here on this list and 1 3 here on that list. So when I write my list, I'm going to have a 3. Now, it goes in terms of small numbers to big numbers. 3 is my bigger number. He's going to go at the end. Now I count how many 2s they have the same. So these guys have 1, 2, 3, 4. And over here, what did I get? I got 4 2s. Same thing. So I got 1, 2, 3, 4s. Okay? So this would be how your prime factorization is written. It's all of these bottom numbers that are prime numbers. They could be listed like this. They could be listed like this. Those are all of your prime numbers. There's another way to find prime numbers, and it's called a division table. So I'm going to show you the number 27 with a division table. Pardon me. Whoops, I need my other color. So some people like a division table. So I'm going to do this one with a division table. This one just goes straight down. So I start my number, and I make an L around my number. And now I try to decide what will 27 divide by. Well, 27 is an odd number. So if he's an odd number, I'm going to start dividing by 3 because it doesn't end in a 5. So it does divide by 3. I get a 9. Now I've got to divide that 9. 9 will divide by 3. It's an odd number again. And it gives me a 3. 3 will divide by 3 again and give me a 1. So what's actually happening is this. 27 is dividing by that number and giving me that number. Okay, so it's kind of a jigsaw. So you've got your first number. At the very top, he divides by the guy on the left, and that becomes your new number underneath. He's going to divide by the guy on the left and give a new number underneath. He's going to divide by the guy on the left and give a new number on the left or on the right underneath. What you're going to notice with division tables is you need to take them all the way down to the number 1. Okay? It's different than a tree chart because tree charts don't have a digit 1 in them. You always got to get it down to the 1. Now, when you do it this way, your prime numbers are all going to be on the left-hand side. So my prime numbers are the 3, 3, and 3. So if I were to do this like this, here are my list of prime numbers. And I'm going to show you how to do it again with a tree chart. So with a tree diagram, I would have 27. It's odd. He divides by 3. And that gives me 9. 9 divides by 3 and gives me a 3. Okay? So if I do my tree chart, my tree diagram, I get the exact same answer. I get a 3 and a 3 and a 3. I get 3 3s on the bottom. So that tells me that my prime factorization of 27 is going to look like 3 times 3 times 3. Final answer. And that is called repeated multiplication. It is written where all the numbers are being times, all your prime numbers. Okay, that is your final answer. Okay, we're going to do 72. It's a bigger number now. We're going to start with the number 72, and we're going to do it both ways. So on the left, I'm going to do the division table. So I start with 72 and I make my letter L. 72 is even, so I'm going to divide it by the number 2. My answer goes underneath. That's going to give me a 36. It's an even number, so I'm going to divide that guy by a 2 to give me my new number, which is going to be an 18, who is also even. Once it recognizes my pen again, come on. Here, let's change colors, maybe that'll help. Starting, here we go. So we take 18, he's even, which means he's going to divide by 2 and give me my new number, which is going to be a 9. Now 9 is an odd number. So odd numbers now start dividing by 3. That's going to leave me a 3. So I'm going to divide by a 3 again, because 3 does divide by 3, and I get my 1 left over. So I want to tell me my 72, come on, don't freeze again. 72 is going to make 2 times 2. I have 3 2s and 2 3s. Whoopsie, that should have been a 3. A 3 and 1 more 3. Okay, and now I'm going to do the tree diagram right underneath that so you can see how to do that. Now, do I have to start with the number 2 in a tree diagram? We see in the question above, no, I don't have to start with the number 2. They're just going to be different spokes of your tree, and they will come down anyways. So with the number 2, I'm going to start with a different one. Let's start with, for 72, it's going to be 8 times 9. So let's try that guy. 8 times 9 makes a 72. Well, we know 8 divides by 2. It's an even number. 2 times 4. And 4 divides by 2, an even number, and I get 2 times 2. All right, the number 9 is an odd number. Okay, that guy was even, so we divided by 2. This guy is odd, so we're going to divide by 3, and we get 3. Okay, so now we can see exactly how many 2s we have and how many 3s we have. So in our final answer, we get the same amount. I have 3 2s, 1, 2, 3 2s. I end up with 2 3s. I end up with 2 3s. So you're going to get the same answer whichever way you do it. It doesn't matter. Whichever way you find the easiest, that's the way I want you to do it. Okay? All right. This is now your time to work on the assignment for lesson 4. You've got the rest of the period to work on it. This is the end of lesson 1.4.